8.5, we're talking about trigonometric form. I will be calling it polar form. Okay? Polar form, you're going to need r and theta, but all that is magnitude and direction. So when we're talking about polar form, we're really just talking about magnitude and direction. So then they start off with something that I think you should already be familiar with. They give you a vector in this form. This is called rectangular form, where they're giving you an x and a y, basically. So you might be more comfortable calling it 2, negative 3 inside pointy brackets. But they're going to write it in this rectangular form with the I on it for rectangular form. So check out this diagram down here. They've got a resultant force drawn. But notice the two vectors. Let's call this vector A. This is vector A, 4 plus I. And let's call this vector B, 1 plus 3I. They're just adding these two vectors. It is pretty easy to see where that 5 comes from. Just add the x coordinates. 4 plus 1 is 5. And then add the y components. I plus 3I is 4I. That's how they're getting their resultants. Okay? Their A plus B, or their resultant force in this picture, is just drawn by adding the components. Add the x's, add the y's. So example 1 is an example of that. Find the sum of these two vectors and then graph both complex numbers and their result. We're going to graph a total of how many vectors here? 3. We're going to graph both of the vectors that they show, plus we're also going to graph the resultants. We're going to graph 3 vectors. So first thing, let's find the sum. That's easy. Okay? Find the sum. We're going to add the x parts. 6 plus negative 4 is 2. Add the y parts. Negative 2i minus 3i is negative 5i. So there's your sum of those two complex numbers, or your sum of those two vectors, your resultant. Now we need to graph both complex numbers and the result. So if you look, the numbers go up to 6. I'm going to need to draw an xy coordinate plane, but I only need to go up to 6. The first vector, 6 minus 2i, treated just like 6 comma negative 2. That's where the head of your vertex would go. So go over to 6 and negative 2. That's where the vector is going to end up. That's 6 minus 2i. And then the other one says negative 4 minus 3i. So look at negative 4 comma negative 3. That right there. Negative 4 minus 3i. So we've graphed our two original vectors. We've graphed our two vectors. Now we're also going to graph the resultant, 2 minus 5i. So 2 minus 5i is going to be about right there. And so remember back to some of the sections before where we've had to draw the resultants. This looks like a dog walker problem, and that resultant vector should be to the opposite corner of our parallelogram. You think that's what happened? Looks about right. Don't draw that in. They don't really care for us to draw that parallelogram. They wanted us to draw those two vectors, those two complex numbers, and the resultant. So that's it.
Check out these formulas. These are important. Also, check out this box right here. It looks really confusing, but there's a really useful shortcut.
Example 2, express 2 times the quantity cosine 300 plus I sine 300 in rectangular form. Okay? So what I would want to pay attention to is they want rectangular form, which means that they want x and y. Okay? I want x and y. Now also, they've given me polar form, which means they've given me r is 2 and theta is 300 degrees. Okay? So all we're doing is converting from knowing this polar form, this magnitude and direction. That's what this is. This is magnitude and this is direction. They're giving us the magnitude and direction, and they want the x and the y coordinates. Okay? So we have formulas for that, right? What's the formula for x?
Magnitude, cosine, direction.
Good. Magnitude times cosine of the direction angle. So all we're doing is 2 cosine 300. 2 cosine 300 is 1. Is that right? 1. That's your x component. That's your horizontal component. And so what about y? 2 sine 300. 2 sine 300 is negative 1.73. About negative 1.73. Okay? So rectangular form, really looks like this. X plus I times I. And so if we want to put it in rectangular form, we just write this in that form. And so we're going to have the x component with 1, and I guess we got a minus here. Minus I times 1.73. It's going to look something like this. Okay. Now, if you wanted the exact answer, that's approximate, but 300, you might recognize 300 comes from the chart. Okay. 300 comes from the chart, right? 300 is a 60-degree reference. And so we could get an exact answer. Maybe it would be better if we did an exact answer there. Okay? Sine 300, you got to look at sine 60 in the fourth quadrant. Okay? Sine 60 is square root of 3 over 2. Square root of 3 over 2 in the fourth quadrant. What happens to sine numbers in the fourth quadrant? So we'd have 2 for the magnitude times sine 300. 2's cancel and we get negative square root of 3. Okay, so that negative 1.73 number, that's negative square root of 3. And so maybe a better answer would be 1 minus I times the square root of 3. That's exact. That's exact, so that's probably the better answer. Typically, when your angle puts us in the chart, you want to use the chart. If your angle is not in the chart, then you can dig out the calculator. Example 3a says to write negative square root of 3 plus I in trigonometric form. That means polar form. Okay, polar form wants magnitude and direction, or in other words, r and theta. Okay, we're looking for r and theta. And so in order to do that, think about what they've given us. They have given us rectangular form, which is x and y. X being negative square root of 3, and y, well, there's just a 1 there, right, with the I. Y is 1. So we've got our x component and our y component. We need to take those x and y and change them into the magnitude and direction. Okay? So your r, we know r equals x squared plus y squared. That's the magnitude. And so we're going to have a magnitude equal to the square root of negative square root of 3 squared plus 1 squared. Square root of 3 squared is 3. So we're going to have square root of 3 plus 1, square root of 4, that's 2. The magnitude is 2. Okay, the length of that vector is 2. That's what that's saying, right? Okay, so then let's find theta. Now notice they said they want us to use radian measure. Okay. Tangent theta equals y over x. We're looking at that. Okay. Now, if we were using our calculator, if we were using our calculator, we put it in radian mode, and we would just do inverse tangent of, 1 over square root of 3. Okay? But that's kind of hard to read in radians. All right? It would be that number right there, that 0.523, that number would be the reference angle where tangent is negative, so we still have to think about where that is. But I get the feeling they don't want us to use our calculator here. Okay? And the reason that I know that is because I recognize these numbers from the chart. See a square root of 3? You've got 1 over square root of 3, which is in the chart. If you find the 1 over square root of 3, that's talking about right here, right? 30-degree angle, or pi over 6, since we're in radians. Pi over 6. Okay? That is a pi over 6 reference where tangent is negative. Okay? Pi over 6 reference where tangent is negative. I wonder, what is pi over 6? 0.523. So that 0.523 number is pi over 6. That's what we got. Okay? So we've got a pi over 6 reference where tangent is negative, but we should be able to tell what quadrant we're in anyway. Okay? When x is negative and y is positive, what quadrant is that? Second quadrant. Okay, so we've got a pi over 6 reference in the second quadrant. You guys good enough at this to know what that angle would be then? Remember, this is pi. Get a common denominator. I call that 6 pi over 6. 5 pi over 6. Theta is going to equal 5 pi over 6. Okay? So, I've got the magnitude. The magnitude was 2. And the direction angle is 5 pi over 6. So if I have to write it in polar form, okay, remember that's what they asked me to do, right? Write it in polar form. That means magnitude times cosine of that angle plus I sine of that angle. That's polar form. Or the abbreviated version looks like 2 cis 5 pi over 6. I don't know about you, but I would rather use the abbreviated version. 2 cis 5 pi over 6 seems a lot easier to write. Okay, one or the other, that's polar form. So let's go ahead and do example 3b. It's basically the same thing, only they want us in degree measure. Okay, use degrees. They want trig form, which means they want r and theta. Notice they only give me this negative 3i. Well, we would want to think about that as 0 minus 3i, because you're going to have an x and a y. You have to think about the x and the y coordinate, and you should be able to tell that x here is 0 and y is negative 3. Okay? You got an x coordinate of 0, you got a y coordinate of negative 3. If we want trig form or polar form, we want magnitude and direction. So let's find the magnitude. X squared plus y squared. Square root of x squared plus y squared. Square root of 0 plus 9, that's square root of 9, that's 3. Okay? So I've got a magnitude of 3 there, magnitude of 3. And then we want to look at the angle. So tangent theta equals y over x. Notice that's undefined. I don't think we're going to be able to plug that into our calculator. Okay? So you can try it. But I think it's going to help us to visualize where this is. Okay? Let's visualize where negative 3i would be. If I go over 0 and down 3, this vector puts us right there. Okay, incidentally, look at how long that vector is. What's the magnitude of that vector? Well, we just calculated that magnitude was 3, but isn't it obvious from the picture that that magnitude or length is going to be 3? Pretty obvious. It's 3. Okay? But then as for our angle, we can just look at the picture and tell what that angle is. That's 270, right? That's a 90-degree reference angle downstairs. That's 270. Theta equals 270 degrees. And so if we write polar form, it's going to be 3 times the quantity cosine 270 plus I sine 270 degrees, or in abbreviated version, 3 cis 270. Again, I think most of you are going to prefer the abbreviated version, 2 cis 270, and that's going to be fine with me. Example 4, write each complex number in its alternative form using a calculator if you need. Okay, so if you look at example A, I can see that I have R and theta. I have R and theta. That means I'm in polar form. That means I must need X and Y. They're asking me to change it to the other form. So let's change to the other form. I need X and Y. X equals R cosine theta, and Y equals R sine theta. Need degrees. Need to be in degrees here. So 6 cosine 115 and 6 sine 115. Looks like we would have our X value is negative 2.54 and our Y value is, oops, I don't want to write it in that form. I want to write it in this form. Negative 2.54 plus 5.44i. Rectangular form shows me the X and the Y coordinate. And so we look at the other part. The other part has X and Y. That means we need R and theta. They're asking me to change to the other form. So if they need R and theta, that means we're changing to polar form. So we know our formula for R, square root of 5 squared plus negative 4 squared. That's square root of 25 plus 16, or square root of 41. I'd probably just leave it as square root of 41 and not worry about the decimal version. You can if you want to. As for theta, tangent theta I know is y over x. And so let's do an inverse tangent on that. Inverse tangent, negative 4 fifths. That negative doesn't really do anything for me. It's just talking about where we are. So here, when I get that out of the calculator, I see a 38.7 degree angle where tangent is negative. Well, let's think about where we are. We can tell specifically if x is positive and y is negative. What quadrant does that put me in? X is positive, y is negative, puts me in the 4th quadrant. So I've got a 38.7 degree reference in the 4th quadrant. So that means theta is 321.3. So I've got R is square root of 41. I've got theta is 321.3. So polar form is going to be square root of 41 cis 321.3 degrees. You put it in a longer form if you want to. The longer form is going to look like square root of 41 times cosine 321.3 degrees plus I sine 321.3 degrees. Same thing. The product theorem allows us to multiply two vectors in polar form. So if you had something like this, 8 cis 40 degrees times 2 cis 13 degrees, we're going to end up having 16 cis 53 degrees. That's the product. So in general form, I like its compact form. You multiply the two magnitudes, and you're going to add the two angles. So let's see an example. Example 6, find the product of these two vectors. So let's write it in abbreviated form. 3 cis 45 degrees times 2 cis 135. We're going to multiply the magnitudes. 3 times 2 is 6. And we're going to add the angles. 45 plus 135 is 180. So really that's it. That's the product, but they ask us for rectangular form. So that's what makes this problem a little bit more complicated. Remember, rectangular form, we're going to need x and y. We have currently r and theta, but they want x and y. So we have formulas for that. X is going to be r times cosine theta, and y is going to be r times sine theta. Cosine 180. Maybe we want to draw a picture of 180. About 180 degrees is over here. So if you think about it from a reference angle, that's a 0 degree reference. And so you want to look at cosine of 0. Cosine of 0 is 1. But if you think about where we are over here on the left side, cosine 180 is going to be negative. Cosine is negative on that left side. So cosine 180 is negative 1 times the 6, gives me an x component of negative 6. As for sine 180, again, we're over here, but sine 0 degrees is 0. So sine 180 is 0. We have 6 times 0 is 0. So if we have to write this in rectangular form, this was polar form. But if I have to write it in rectangular form, take your x component plus your y component with an I. Now, of course, we can simplify that and just say negative 6. And I suspect Math Excel is going to make us simplify. But honestly, I would prefer if you left it in xy form like this. Negative 6 plus 0i. So if we do the quotient theorem allows me to divide. So if you had something like 40 cis 100 divided by 5 cis 25, we're going to get 8 cis 75. And so hopefully you can see that we're going to divide the magnitudes. We're going to subtract the angles. So there's a rule for that. Example 7 uses the quotient rule to divide two vectors. We can see 10 divided by 5 is equal to 2. And then we're going to subtract the angles. Negative 60 minus 150 is negative 210. So we have 2 cis negative 210 degrees. That would be awesome if we could leave it, but since this wants rectangular form, they're wanting x and y. Okay? What we have is polar form with r and theta. So rectangular form is going to look like x equals 2 cosine negative 210 degrees, y equals 2 sine negative 210 degrees. So let's look at 210 degrees, or negative 210 degrees. Negative 210 takes us past negative 180 into the second quadrant. It's a 30-degree reference in the second quadrant. So when you do cosine negative 210, it's kind of like you're doing cosine 30. Cosine 30 is square root of 3 over 2. But think about where we are. In the second quadrant, cosine is going to be negative. So cosine negative 210 is negative square root of 3 over 2. We're taking this 2 times negative square root of 3 over 2, and that's a negative square root of 3. If we do sine negative 210, that's like sine 30, and sine 30 is 1/2. So again, think about where we are in the second quadrant. Sine is positive there, so sine negative 210 will also be positive, 1/2. And so the y-coordinate is going to be 2 times 1/2, that's 1. So if you have your x component and you have your y component, then we should have rectangular form. Rectangular form is going to look like negative square root of 3 plus 1i, or just I.